Hello and welcome to today's lesson. In this lesson, we'll be adding mixed fractions together. Let's get started. Sometimes we are asked to add a mixed fraction to a whole number. So how do we go about it? Well, you recall that mixed fractions are fractions that have a whole number component as well as a fractional component. In this example, we have the mixed fraction here has a whole number component which is 5 and a fractional component which is 1/8. Well, we can see this mixed fraction in another light. Well, I want you to realize that 5 1/8 can also be the same as 5 plus 1/8. If you add 1/8 to 5, what you have is 5 1/8. Okay, so if it is this way, then this can help us in adding this fraction. So we can go ahead and add plus 2. Now it doesn't matter where the position of the whole numbers are, it still gives you the same answer as long as you are adding. When you are subtracting, it's a little bit tricky. The same rule can still work, but you have to be very careful. When we get to subtraction, I will point your attention to this. So it doesn't really matter where the position is because of the commutative property of adding fractions. So we can go ahead and say this is the same as 5 plus 2 plus 1/8. So when you add 5 to 2, that gives you 7, and plus 1/8, so it's going to be plus 1/8. And you recall that we said 5 1/8, one way of writing it is this way. So 7 plus 1/8 is the same as 7 1/8. There's a second method by which you can solve this problem, and that second method involves you using converting this mixed fraction into an improper fraction. So if we convert the mixed fraction into an improper fraction, that's going to give us 5 multiplied by 8 is going to give us 40, and 40 plus 1, which is the numerator, gives us 41. So 5 1/8 can be written as 41/8 plus 2/1. Recall that 2 is an integer, and in a fraction form it means 2/1, and 2/1 is equal to 2. So now we have converted the whole number and the mixed fraction into a fraction. Both of them are now improper fractions. So what you now want to do is you want to make sure that they both have the same denominator so that you can add them like fractions. So what we need to do is that we need to make 2/1 to have a denominator of 8. So what can we do to 1 to make it 8? That's by multiplying both the numerator and denominator by 8. So 2 times 8 is going to be 16, and 1 times 8 is going to be 8. So this will be 41 plus 16 divided by 8. So if you add this together, 41 plus 16, 1 plus 6 is 7, and 4 plus 1, that's 57/8. Now if you can convert this improper fraction to a mixed fraction, so 8, if you divide 57 by 8, how many times will 8 go through 57? That's 8 times 7 is 56, so that's 7 times. So if we deduct 56 from 57, you are left with 1, so that's 1/8, which is just like the same answer that we got here. So these are two methods which you can use. If you use this method, you can use the second method to check your answer. What if you are adding two mixed fractions together? Does that first method still apply? Let's try it. So the first method said we can write 5 1/8 as 5 plus 1 over 8, and 3, 4 over 5 as 3 plus 4 over 5. Okay, now let's bring all the whole numbers to the same side. Together, 5 plus 3 plus 1 over 8 plus 4 over 5. Now we have the whole numbers on one side and we have the fractional numbers on the other side. So the whole numbers are 8 plus, now we have unlike fractions here, so we can use the equivalent fraction method. So we want to make them have the same denominator. In this case, it's going to be 8 times 5, so we multiply them by the opposite denominator. So 1 over 8 will be multiplied by 5 over 5, 4 over 5 will be multiplied by 8 over 8. So 1 over 8 is going to be, the equivalent fraction is going to be 5 over 40, because once you multiply by 5, that gives you 5 times 1 is 5, 5 times 8 is 40, plus the second fraction we multiplied by 8, 8 times 4 is 32, and 8 times 5 is 40. So now we can add them together. So this is going to be 8 plus 5 plus 32 is 37 over 40. So we can write this as 8 37 over 40. What about the second method? In the second method, we can convert each of these fractions into an improper one. So 5 1 over 8 will come up as 41 over 8, plus 5 times 3 is 15, 15 plus 4, that's 19 over 5. 19 over 5. Now both of them are improper fractions. We want to make sure that they have the same denominator. So what do? So we multiply them by the opposite denominator. So we're going to have a denominator of 40. So we multiply 41 over 8 by 5 and 19 over 5 by 8. So 41 times 5 is going to give us 205. So 205 over 40 plus, because 8 times 5 also gives us 40, then 19 times 8 is going to give us 152, divided by 5 times 8 is going to give us 40. So when you add 205 to 152, it's going to give you 357 divided by 40. So 40 times 8 is 320. So that's 8 times. And if you deduct 320 from 357, you are left with 37. So that's 37 over 40. Just the same value that we obtained by the previous method. It's much easier when you are adding fractions, mixed fractions that have the fraction aspect of them they are like fractions. So we have an example here: 2 5 over 8 plus 1 3 over 8. 5 over 8 is very similar to 3 over 8 because they have the same denominator. So it's very straightforward. We can use the first method. So we just say 2 plus 5 over 8 plus 1 plus 3 over 8. So this is going to be 2 plus 1 plus 5 over 8 plus 3 over 8. So this is going to be 2 plus 1 is 3 plus 8 over 8. And what is 8 over 8? That is 1. That is 3 plus 1. It's going to give us 4. So it's very straightforward. You don't need to use the LCM method or use the equivalent fraction method. You just add them straight up. So what did we learn in this lesson? Well, when you are adding mixed fractions, you must take note of whether the fractional portion has like components or unlike components. If they have unlike components, you can use the equivalent fraction method, and that's going to help you to quickly resolve it. Secondly, you can also convert mixed fractions into improper fractions, and this will help you when you are trying to compute the addition, when you're trying to add these two fractions together. That's it on addition of mixed fractions. Thank you for watching.